everyone. My name is Monica Shimamura. I am the director of the Global Methane Initiative, or GMI. I wear a second hat, and I am the wastewater lead. So I just wanted to give a bit of an overview of what GMI is, because it is one of the organizations that's hosting this event. And just to give you a quick overview of what we do, we have multiple sectors that we reduce methane emissions. Our goal is to reduce, reuse, and abate methane emissions. And we do that in the oil and gas sector, coal mine methane, and biogas. And within biogas, we have wastewater, as we're here in the session, as well as agriculture, which is manure management, and landfills, which is what you just heard in the previous session. And then coal mine methane. We have 46 partner countries, and we've been around since 2004. So we were one of the first organizations to work on methane mitigation when no one else was doing it, and we were pushing that conversation. So again, we have a lot of expertise, technical expertise in the area, and we definitely are here to share that with you and grow the field. And this just shows you our partner countries. All the orange is where the countries that we've been working with. Some of the countries, if you are partners or if you work with them, we'd love to continue that collaboration or strengthen it. So again, if you don't see your country or the country that you're working on, please let us know, and we'd love to work with them. And this just gives a little bit of background on what we've done since 2004. We've done quite a lot of work. We grew from 14 partners to 46 partners. We've leveraged, back in the day when other countries weren't, other organizations weren't working on methane, we've leveraged a lot of money to work on methane mitigation projects. And back when we first started, it was about putting pipelines, projects, methane emission reduction work, getting the pipeline going. We've worked with over 740 project network members, which is essentially non-governmental, so private sector, NGOs, multilateral banks, anything that's not a government organization. What we do is we conduct pre-feasibility studies, feasibility studies, study tours. Jennifer and I did a great, wonderful wastewater study tour with our Chinese delegates in the US a couple years ago. We do site visits, we create tools, we do all sorts of things with our resources to get that information out to you and our stakeholders. We've also, one of the things that we've done over the years is we've done a lot of methane emission GHG reduction. So we've reduced over 500 million metric tons of CO2 equivalent, and that includes our partner country organizations working with different countries who are reducing methane emissions. No, I keep going the other way. What for wastewater? Now I know this is a wastewater specific, so I just wanted to talk a little bit about our one of the resources that we have for wastewater, which is the BioWatt tool. And the wastewater sector was created, not created, but for GMI. We started it in 2010, and it's been slowly growing, and we don't have as many resources. So if through this conversation, I'd love it to, if there are areas of gaps, areas of necessity that you can think of, we'd love to hear about it and hear what kind of tools that we could provide as an organization to help kind of move the needle on wastewater methane emission projects around the globe. So the BioWatt tool is something that that the World Bank had started, and GMI took ownership of the project. And it's basically a kind of a preliminary assessment to kind of see if the wastewater treatment facility has capacity, or if there's any way to see, not any way, but a mechanism to see what the methane emissions, the capturing of that would be, what the capacity of that would be, what would it look like. It's a very dirty, quick assessment, but it gives a nice picture of what the ability of that facility would be. And again, this is for use for anyone on our website. It's free. You can take it and use it where you need to. And if we if there's a better way to enhance it, we'd also love to hear from you of any mechanisms to improve or make it refined. So we've done, you'll hear a little bit more about this through my colleague Rogelio here in the audience tomorrow, but we've done a lot of work in Mexico over the years. And some of the work that we've done is we've done some pre-feasibility studies in Mexico. And in the last, I would say, pre-COVID, we were able to do several pre-feasibility studies and look at the capacity of some of the wastewater treatment facilities in Mexico, again, if they are able to reduce methane emissions and what the cost would look like, what the energy capacity would look like, what was necessary for that to take place. And so you can see these are the 3 plants. They were located in urban areas. We looked at Monclova, Atapaneo, and Nacalpan, 3 locations in Mexico, and looked at their, again, capacity for wastewater for methane reductions, biogas production in these facilities. They're at different stages, and again, we could take the projects and move further and see what else they could do to enhance that, because they're still kind of at a standstill and looking at the studies. The other thing we did in Mexico, again, through our work with Tetra Tech and Rogelio, we looked at financing. We've done a lot of workshops in Mexico, and what keeps coming up is money. We need money to do this. Working on biogas capture at wastewater treatment plants, it costs a lot of money, as people know here. And one of the things we were trying to figure out is, what can we do? What tools can we provide to figure out how we can get funding? What are the barriers for funding? So we did a study looking at methane capture projects specifically in Mexico, and looking at public-private partnerships. And Mexico has a lot of rules and regulations on what needs to be for funding. So we specifically looked and dug deep to figure out what is it? What are the rules? What are the necessities for funding? Looking at what's needed for these facilities to get projects moving. And it's quite a detailed report, and it's on the GMI, the globalmethane.org website for your download to look if you're working in projects in Mexico. Again, there's a lot of information that's super helpful, hopefully, to those who could look at it and figure out if you want to do projects in Mexico. And this is what GMI does. We're trying to give resources. If there's funders out there to look, USAID, if USAID is looking at projects, these are the tools that we're trying to promote and to help that project development go forward. And another area, another country that we've been working in GMI is Kazakhstan. There's been a lot of interest in biogas in Kazakhstan, and specifically in wastewater. And hopefully we'll talk about this in the next two days of sessions. But I think what I've experienced through GMI is that there are countries that are very interested in working on it, but there's also a need to look at the size. Do they have a wastewater structure? A lot of countries don't have the facilities of capturing wastewater. So if they don't have it, we're starting from the basics. And I know that Jennifer and James and Emily will be talking a little bit more about this. But we did some work in Kazakhstan to look at the feasibility of methane capture at these facilities that are aging, that need to be developed or not rebuilt, but revitalized. So we're looking at those facilities to see if it makes sense to get a biogas digester there and capturing the methane. Again, just quickly, and you'll hear about this tomorrow through our colleague Jose, but we've done some pre-feasibility studies in Kazakhstan. And again, I don't want to go into it because I know that my colleagues will talk about it, but just to give you a flavor of what GMI does. Not moving. Okay. And today, what I really wanted to just share is in the next 2 days, I'd really like to look at what can we do to move the needle in the wastewater sector on methane capture? Because I think this is the venue to talk about what is it that we need to do? How can we do this? Is it co-digestion? Is it looking more at sludge management? Are there energy and financial incentives that the country doesn't have, like the North American or Western European countries? So what is it that needs to be addressed or looked at for these projects to move forward? And I love to have a discussion looking at, in the next couple of days, how can we move that needle? What is it that's needed? And hopefully we'll have a really rich discussion through our 2 days of 2 wastewater panels. And so with that, I do want to give it to Jennifer. Oh, thank you.
Hey there. Going to ask James to come on up here. Yeah, so my name's Jennifer Turner, and I direct the China Environment Forum at the Woodrow Wilson Center. I'll be giving a talk at the end here, but I'm really into water. But and so you'll hear my stories about taking Chinese on poop to power tours in the U.S. But we're going to start off with James Fotouhi, who is going to start us off closer to home, talking about DC Water's methane abate. DC Water's Metro carbon inventory. Why did I wrote words that didn't make any sense there? So yeah, we're going to come on up, James. It's going to talk about the carbon inventory that they're doing, like putting into practice some of the things that Monica was talking about. Sorry, I bungled that up for you.
No, it's okay. Thanks, Jennifer. Hi, everybody. As she said, my name is James Fotouhi. I work at DC Water. I work in the Department of Resource Recovery, and in particular, my focus is on biosolids. Got all dressed up today, but to be honest, really just a shit operator. To be more specific, I'm a shit salesman. That's what I do. Yesterday, my boots were caked in biosolids, so look nice every now and again. But what I really do is I sell recycled material. So we're going to talk about kind of what is DC Water. So we have a pretty large service area. It encompasses DC, parts of Maryland and PG, Montgomery County, as well as Fairfax and Loudoun. We have 1,900 linear miles of sewer mains and about 900 linear miles of water distribution mains. So it's a very large service area that we manage, and that has implications for our overall carbon footprint, in particular methane production. Right. So now, as you can imagine, the largest source of our emissions is, in fact, our centralized wastewater treatment plant. This is Blue Plains. It's just across the river. If you ever fly into Reagan, you can see it out your window on the east side of the river. This is a 200-acre site. We have a design capacity of 370 million gallons per day. Generally operate about 270 million gallons per day of full wastewater treatment. It's advanced wastewater treatment, so we do primary, secondary, and tertiary treatment at the facility. We also built a very comprehensive carbon inventory for our entire authority. I'm not bragging when I say it's probably one of the most advanced ones in the water sector. Especially in the US, we don't really have any incentive to track this, but for our own purposes, we wanted to track where are our carbon intensities in anticipation of potential regulations. And also for our own understanding, so we could, when we're looking at capital planning, we can make decisions on like where are our largest sources of carbon, methane, and how can we reduce them? So it consists of a few different things. Scope 1 is primarily process emissions, and a lot of that is at Blue Plains, and that's going to include chemical usage. We also have tracked sewer methane. That's a pretty large source. So that's dissolved methane that's going to get produced in your sewer, and it's going to off-gas in the headspace of the sewer, and it's going to come out whenever it's open to air. Then we also have vehicle usage, equipment usage on site. Those are our primary Scope 1 emissions. Scope 2, as you can imagine, electricity, which is a large one, and natural gas usage for heating. And then we have Scope 3, which is chemical production. So what's the life cycle cost of chemicals we use? And then biosolids residual management. And that one is highly variable depending on what you do with solids. So here is our past decade of emissions. So starting in 2012, you can see quite a large change over the first years of this. And in particular, you can see that the electricity demand, the green bar, shrinks by a lot. So I'm going to go through some of the capital projects that have led to that. But yeah, as you can see, like 50% of our usage is electricity. We have a lot in, so the yellow one is chemical production. Chemical usage is actually covered under process emissions. And then you can see the biosolids one is highly variable. We'll go into exactly why that is, but again, it depends on what we're going to ultimately do with that. So the capital upgrades that in particular have impacted our carbon footprint were the ENR upgrade. When we had a change in our consent decree with the EPA, they lowered our nitrogen removal levels, so we had to take even more nitrogen out. That was a $1 billion project. Consequently, we had to increase our denitrification system and use more methanol. That's direct usage, non-anthropogenic, so that's where we have to account for that. And then 2015, we completed thermal hydrolysis digester upgrade. So we used to produce Class B, which is Class B biosolid, which you can reuse, but it has limitations because it still has pathogens. And then we went to a Class A biosolid, exceptional quality, which we can use in any capacity. In particular, this project pasteurized the material. It also really reduced the volume. So it's one of the few projects in the wastewater sector where we actually made a return on investment. About 15 years, we're going to make our money back because of the reduction in the amount of trucks that we need to move the solids. So it's a pretty good project. And the added benefit is we produce a really high quality residual, which we market and sell in the district. And then the final one is the tunnel dewatering pump station. If you're in DC, you know about the CSO capture tunnel, the Anacostia River tunnel that was completed. First section in 2018, you've got the Northeast Boundary tunnel coming in shortly, and then potentially the Potomac tunnel as well. And basically that's a tunnel that's capturing all the CSO. It's several billion gallons per year. And there's a big shaft built at Blue Plains. It's about 100 feet deep, so you got a big old pump station. So that increased our electricity usage quite a bit. So these are all the projects that kind of impacted our overall carbon footprint in the last decade. Here is a look at the thermal hydrolysis digestion system. A particular note is, you know, we went to mesophilic anaerobic digestion from lime stabilization. So we eliminated a lot of chemicals. We're not using lime anymore. We're also producing biogas, generating electricity. There's a really nice, we capture the steam from that, return it to the Canby system, which basically is like a pressure cooker. You cook it at 150 C for 30 minutes, pasteurizes the material, also lyses it when you depressurize it, so it makes it easier to digest. You get more biogas, so we generate a lot of energy. We make it renewable energy credits out of that as well, and then we make a Class A biosolid. Here's a look at the kind of energy profile. This is from June 2022. So generally, every month we generate about 25 to 30% of our own power. So again, we're not quite at full net zero. We have some projects in the pipeline that could potentially get us there. Building solar panels on reservoirs; those are already we're in the RFP stage for that. There's also a project to put solar panels over the sedimentation basins. That'd be another 12 megawatts. And then there's a centralized heating and capture system, which could, again, offset the energy usage of the plant. So we could potentially get to net energy neutral. But right now, we generate about 30% of our energy, which is pretty great because, again, it's about 25, 27 megawatts per hour. So it's a pretty substantial energy usage over the plant. Now, let's get into sludge. So this is our Class A material. We've called it Bloom. We market it. It's a very stable product, has low odor, and as a consequence, we can sell it. I can take it to a farmer, and they're like, "This is the best thing ever," relative to other sludges, of course. And I can also mix it with other materials and sell it to landscapers, sell it to homeowners. It's a really nice material. We have one of the best marketing programs in the entire country. We sell about 50,000, 55,000 wet tons of this material a year, and that's only growing. So we built a really nice, we've got several hundred customers in Maryland, DC, Virginia. So we built a great program. Here's our label there. We're called Bloom Soil, if you ever heard of that. So this is actually a project on Route 5 in Brandywine. Again, we do a lot of stuff in construction. It's great for turf grass because we have that organic nitrogen. So this was a pretty nice project we did back in 2017. We also are all throughout the district. You know, we're used as a nutrified mulch on Mall. Clean Rivers used us as a topsoil blend. We're at the Fort Belvedere project. We made a nice wood fines blend where we mix it with recycled wood mulch fines. And so, yeah, we have a lot of different customers and different markets. And as a consequence, we beneficially reuse all of our solids and avoid landfilling, incineration, and any sort of that negative carbon production. But we're here to talk about methane. Let's talk about methane. We have three major sources. Sewers, which is sort of a new source. There's a fellow, John Willis at Brown and Caldwell. He's been doing a lot of research on this to understand how much methane is being generated, and the answer is it's a lot. It's about 10% of our scope 1 and 2 emissions would be accounted for by methane loss in the sewer. And that's kind of on the lower end of the estimate, could be a little bit more, could be quite a lot, a bit more. So that's a pretty substantial source, and it's a challenging one too, because you're talking about in parts per million concentration. So capturing that is fairly infeasible. So again, it's a challenging one to manage, but it is one that's there for all wastewater plants, and it's one that we should understand when we're going to look at how we're going to offset our carbon emissions and our carbon equivalent emissions. And then we've got the digester, CHP. Again, because it's biogas, you have a variable production of methane. So sometimes you produce more than you need, sometimes you produce a little bit less, and you have to change your operational protocol with your turbines. And so sometimes we have to flare it, and you get a little bit of leakage there. It's not very much, but it is somewhat significant. It's non-trivial. And then we have our biosolids. This is actually a photo from an event we did at a ball field in I want to say Eastern Market. Yeah. So again, we sell it all over the district because it's a Class A material, as opposed to going to the landfill generating methane. So this is looking at our those methane sources over the past 10 years. So you can see the sewer methane, the dark blue bar there, it's pretty static. It's an extrapolation based on our flow rate and our temperature in the sewer, which is fairly uniform year over year, you know, colder in the winter, a little bit warmer in the summer. And that's about 11 to 12,000 metric tons carbon equivalent. Then you got a little bit with the digester gas that you're losing, but the biosolids is incredibly variable. So in 2013 and 2014, that was when we were doing our upgrade project. You run into these scenarios where we used to produce 400,000 wet tons of biosolids a year, line stabilized. And sometimes you have bad weather. Sometimes the contractors don't have space for it, and you have to go to a landfill. And the consequence is pretty severe. So that's about 20, 30,000 wet tons going to a landfill and generating methane. It's a substantial source of carbon emissions. And one that we should try to avoid, because again, if we had to send all of our biosolids to the landfill, we would increase our overall inventory by 70%. So that's both in terms of increasing the carbon emissions, but then also you lose some of the carbon credit benefits because you're not sequestering carbon. There's a lot of great research. University of California, Merced, looking at 10, 20-year studies on organic amendments, improving the soil quality and building up soil carbon over time. And then also you're not offsetting chemical nutrients. And so this is a big risk because right now, I'm not sure if you're aware, but there's regulations that are going to potentially undermine our ability to sell this material. You know, we're one of the foremost programs, but we're facing regulations because of perfluorinated compounds that are not going to give us a lot of management options. And this is not going to just impact us, it's going to impact food waste as well, because these materials are in food packaging. So food waste composting, they're going to struggle as well. And we're all here today looking at organics diversion, but there's not a lot of options. Nobody's building new incinerators. Landfills don't want to take organics. So I'm faced with, I have a really good option. I have a great program, but potentially in a few years, I might not have anywhere to put it. So I guess I'll just dump it in the Potomac. Anyway, the consequence, so about 50% of the US biosolids in the US are beneficially reused, and that's about 3.5 million dry tons per year. If all of that had to go to the landfill, which is, we're facing it. I mean, we have a biosolids ban in Maine, in Michigan, so it's definitely on the horizon. It would equate to about 6.5 million metric tons per year of carbon equivalent emissions. again, it's like 400,000 metric tons of CH4 emissions. So pretty substantial, and it would be pretty unfortunate because, again, we live in this world where we are very, very dependent on, there we go, on fertilizer. Nitrogen fertilizer is in huge demand. It's required for our current society. And if we're going to build this circular economy, if we're going to move beyond fossil fuels, we need alternatives. We need alternatives to phosphate, which is mined. We need alternatives to nitrogen fertilizer, which is made through the Haber-Bosch process. That's 1% of the world's primary energy used just for this thing to produce nitrogen fertilizer. And so organic amendments like biosolids are a critical part of that pathway. And if we're just going to throw it in the landfill, or if we're just going to incinerate it, we lose a pretty important component of our sustainable future. So it's pretty important that we look at this holistically. I'm not against regulation. Again, I'm sort of on the ground implementing it, and I've tried to navigate. I have 5 state permits. I have to submit 5 different reports in addition to the EPA report every month. It's a lot. I'm fine with regulations. Regulations are good. I have to test for 300 different compounds that I submit to all those regulators. Now, can you guess how many compounds fertilizer has to test for? They just have to test for the primary nutrient. That's all they got to do. They don't got to do nothing else. So that's fine. We're biosolid. I get it. But it can be a struggle to operate in this environment, and I have to deal with states that have changing rules on what I can do with this material. And even though this is a practice that we all agree is on the net environmentally beneficial, again, if new research comes out that is poisoning us and we're all dying, then obviously it's not a good thing to do. But you need to look at these things holistically. So I hope that the EPA Office of Air talk to the EPA Office of Water, because their decisions impact each other. I mean, this is a substantial increase in emissions. And a loss of a critical component of the water, food, energy nexus. So anyway, that's the message I wanted to send. I'm going to leave on a little bit of a happier note because that was a bit of a bummer. So these are some photos from some of our great projects. If you recognize the top photo on the right, that is that new Frederick Douglass Bridge. We are actually being used on the turf grass there, and it looks great. Again, organic nitrogen is awesome for turf grass. This is some really tall corn down in Charles County. Again, it's really great for cereal crops, especially in drought-prone areas, because there's a really awesome drought-resistant component to biosolids. And here are some really cool sunflowers. It's kind of like, one had biosolids, one just had some chemical fertilizer, and it's pretty awesome difference. That was from one of our customers up in, I believe, Howard County, flower grower. So again, it's a great amendment, and this is a phrase my boss always uses. There's no waste, there's only wasted resources. There's so many opportunities at a wastewater plant, at a landfill, to find beneficial resources and reuse them. But we need the environments that support that. We need the regulations to incentivize it and support it instead of making it really challenging. So anyway, thank you.
Thanks so much, James. Yeah, so next we've got Emily Bondank from the USAID Center for Water, Security, Sanitation, and Hygiene. And she's going to talk about the potential that USAID sees for advancing methane abatement in the sanitation sector. And kind of excited. We're both in the same building. Did you know that? I'm in Ronald Reagan building too. So we are neighbors. Do you want to have this here, or do you want to hold it? All right, sounds good. All right. Do you want her to click, or you're a clicker?
I'll try to click.
She'll try to click. It's a little sticky.
Okay, that's fine. I'll be patient.
Not like there was anything put in. James is doing it. And I'll give you your time.
Wonderful. That's really appreciated. So hi, everyone. I think I'll actually be serving as a really good foil to James's presentation, given that he was talking about having the most advanced tracking systems and complex but well-meaning regulations that have trade-offs that maybe aren't yet addressed. From the USAID perspective, we're going to be looking at the least developed situations and thinking about methane abatement and how that's feasible in those contexts as well. So to start, since this is maybe mostly a domestic audience, let's see. I'd like to just first overview what the U.S. Agency for International Development is and what our work is in this space generally. So USAID is a federal agency that works to end extreme poverty through a few different avenues. And one of those, and my personal favorite avenues, is by providing long-term foreign assistance on water security, sanitation, and hygiene. We do this through these steps, starting with strengthening water governance and institutions and attracting public and private investment. This is like the cornerstone of our programming. And this leads to, with a little bit of investment in infrastructure as well, to improved piped drinking water services, latrines and sanitation systems, sustained hygiene behaviors, and improved management of water resources. So given that overview of what we do, I'd like to today share how we see our work fitting into the methane abatement space, what we're kind of already planning to do, and what the potential is in our specific context, which turns out to be mostly a fecal sludge management context. And so I'll describe what that is in some detail in order to kind of have a discussion between the comparison of fecal sludge and wastewater. And let's see if the challenges are similar or very different. And then lastly, we have envisioned a path forward for ourselves, but very open to inputs at this stage. We're still in the process of really developing and pushing forward what we want to do. Okay. Just to share also more generally at a climate change level, like at a political level, we are now really contending with addressing climate change in all of our programming across all sectors within USAID. And this is solidified within our, well, our ambition is kind of solidified within our new climate change strategy. I won't walk through what all of these parts of the strategy are, but just know it includes both mitigation and adaptation as part of the strategy. And since we're really talking about mitigation here, I'll just share that our mitigation target in the strategy is to reduce CO2 equivalents in the countries we work in by 6 billion metric tons. And the wastewater / sanitation sector just being one of those avenues. There's also agriculture, energy, and solid waste sectors at USAID working on this. Also, just to share more generally on climate change, we have gone beyond an agency strategy and are also developing implementation guidance for our programming around the world. And we have just published this climate resilient low emissions water security and sanitation tech brief that's available online publicly if anyone's interested to look at generally what our strategy or implementation strategy is going forward in our sector. Noting that we've kind of outlined, this is like a figure that describes our overall kind of framework of what we think needs to happen, and it includes both building blocks, including like policy and regulation, data and analysis, finance, etc., and also some practices and key principles that we think USAID in particular should move forward. Okay, then I'll also share, getting to methane more in particular, we also have some motivation from the interagency and from the Special Presidential Envoy on Climate to advance work on methane abatement, because as a short-lived climate pollutant, it's very urgent to address this, especially in comparison to CO2. It's something that we need to address now in order to reduce temperatures in the way that we want to. So we've mobilized together. I've worked with Monica from time to time now from EPA, and also we have like a working group in our agency that includes all of the relevant sectors that need to move forward on this. Okay, so now for specifics, we've started to put our heads together at the agency through that working group to think about what the potential is for methane abatement in our programming. And what we've noticed is that within like the water security, sanitation, and hygiene sector, sanitation subsector is the one that really contributes, producing 7 to 10% of anthropogenic methane globally. And the growth projected for methane emissions in the future, we learn will largely come from low and middle income countries where we work in Africa, the Middle East, Asia, and Central and South America. And so that kind of puts the onus on us to really contribute in this space. And this does make sense to us as being something we should address, because we know that 80 to 90% of the wastewater in the countries where we work is neither collected nor treated. And when we look at what the sanitation kind of sector looks like in the countries that we work in, we know that it's rarely through centralized wastewater treatment systems when we do improve sanitation access. Instead, mostly what we provide is fecal sludge management systems consisting of latrines, pit emptying, transport, and treatment, and disposal and reuse. So this slide just shows some examples for South Africa and Central and South Asia, showing that amongst the options for sanitation systems, the darkest colored option, and being sewer systems, are the least percentage of what we see. So in each case, and this is true around the world, it's going to be very, very little percentage of what we see. So therefore, we really think where the potential lies for us is in improving fecal sludge management to also include methane abatement. And so the first step for us is to discover what is that context for what makes, well, what could make that work, or what are the challenges that we see specifically in fecal sludge management versus wastewater. And so getting now into some kind of engineering specifics. This figure shows, first at the top, it shows each stage of the fecal sludge sanitation chain, starting with containment and leading to reuse and disposal. And kind of contrary to what James mentioned in terms of where the emissions happen, where in wastewater, he said that it happens in the sewerage or the transport. For fecal sludge, it really starts with the containment, where waste sits before it's transported by truck, basically. But the thing is that the amount of emissions really vary depending on the type of containment systems shown in examples there, and also in the length of time that it sits in containment based off of frequency of emptying. So in general, containment options that seal in the gases, like lined pit latrines, reduce the amount of methane emitted in that stage. However, the net release of methane emissions also critically depends on treatment and capture. So kind of highlighting this bottom box here, as the frequency of collection and therefore the average time in containment decreases, which is a good thing, it has public health benefits to do that, the methane emissions at the site decreases also, which is good. However, now the emissions potential is carried with that waste to the treatment facility, where now the methane released, it will be greater than if the waste was left in containment longer, if it's not treated properly. So therefore, in order to really reduce the net methane emissions, proper treatment must be paired with increased frequency of collection. So that's something we're finding, is we can't just do the business as normal, improving frequency of collection. We also really have to invest in treatment as well. Oops. Okay. Sorry. I think I need to go one more. Okay. So additionally, when it comes to treatment, fecal sludge is also more concentrated than wastewater is. And this is showing that through a few different kind of imagery. But therefore, treatment must address that in a specific way. Basically, well, you see the fecal sludge at the bottom is just way more thick and concentrated, and so it's just a bit of a challenge. Yeah. Okay. And the characteristics of the waste also vary widely between sites and days. These graphs are showing for different sites within Indonesia, I'm sorry for the small text, the total suspended solids and the biological oxygen demand vary greatly from the average. So you can't really have a real expectation of what you're going to see in any given site, which makes treatment hard. And so ultimately, some of our colleagues at USAID have seen this firsthand, that these challenges can cascade to failure when methane abatement technologies are in place, like, for example, anaerobic digesters. So in this case, this is one of those sites in Indonesia where the digester was clogged and was bypassed, resulting in a disrupting of downstream processes. And also, poor final effluent quality, which is, not achieving our goals of improving water quality or sanitation for all. It's not what USAID wants to do. So the path forward we see in advancing methane abatement, I think, will require knowing more about what treatment processes are feasible and sustainable in our contexts. And maybe, given all of that kind of negativity, it is important to say that we do have some success stories. For example, in our work on sustainable sanitation in urban slums of Kenya, we support a company named Sanergy, where they collect and treat and turn the waste into fertilizers. So our goal kind of is also to understand what are the factors that have led to success in this case, and how can we scale that in other cases that we're working in. And additionally, we do see some potential in a few technologies. For example, container-based sanitation, which would include processes like anaerobic composting, briquette production, also biosolids treatment through aerobic composting or solar drying, and also digesters. But we know in our context, container-based systems are limited in scope and scale. It's kind of a new technology. Biosolids, these processes are add-ons that are expensive and require money. And also digesters for fecal sludge are not a mature technology. And so if there's not a high capacity, if there's not a high technical capacity of operators to manage these systems, it could ultimately fail. And this is just an overview also of some enabling environment factors that we've noted for fecal sludge are basically not there or are site specific. So ultimately, what I'm saying is that we feel like we need more research in order to ensure that we can contribute to reducing methane emissions in low and middle income countries where we work in the long term. We think that if we were to invest now, we could really see significant gains. Also, with some injection of climate finance to build the infrastructure that is needed, but that will be sustainable. We think this could have huge returns. Again, noting that 80 to 90% of waste in the countries where we work is not yet treated, and it will need to be in order to achieve safely managed sanitation for all. So if we can embed methane abatement strategies within those new facilities, strategies and technologies, then it could be huge. So we've developed some initial research questions that we're pushing forward, but I'd love to discuss these more with the experts in the room on wastewater and maybe even fecal sludge. Maybe there's a few of you out there, but we're really hoping to understand. I think this is the key one. It's just like at what scale, what context, under what conditions, and for how long to do these technologies work. Maybe particular digesters. What are some other technologies that may work? Maybe composting is the best option, that kind of thing. So I'll leave it there for now. Thank you. Looking forward to discussions.
Hey there, I'm gonna give the clicking to you. Relinquish power. I can do that. Yeah, hi there. So are we? Oh, we're here. Okay, moving sludge mountains in China. Have any of you any of you been to China? Oh, good. We have a couple of people here. Well, if you've been to China, have you done water stuff there then? No, water. Tourist. Okay. Okay. So all right. So I'm not going to give you a whole history of China, but want to let you know. Let's start off thinking about how in 2014, China started a war on pollution. This is after horrific air quality problems in 2012, 2013. You know, after the Olympics, the skies were blue and then it got pretty bad. And so they started focusing an air pollution action plan. And in 2015, they started a water pollution action plan. Next slide. And I'm a water person. And so we started kind of checking out like, well, what is going on in terms of what is this action plan going to do? And one of the things that we noted in it, it said that by 2020, 90% of wastewater sludge will be sanitary, clean. And I thought, sludge, hadn't thought about sludge before. And then we started poking around, not literally, but more reading. And we found out that in 2013, some citizens had been kind of checking out around outside Beijing. They found 30 hills that were actually wastewater sludge that the wastewater treatment plant had just dumped around the city. And you'll love this, James. They told the farmers, you can just take it. Untreated sludge. Yeah. And so then we started doing investigation. We made this little infographic and kind of to give you the image that how much sludge China was producing. This was back in 2016, and they were only treating about 20% of it. Next slide. And China is an important player in terms of wastewater methane, because you see our little chart here that they account for 1/4 of the world's global methane that comes from wastewater. I don't know, what are we in the US? You know that, James? That's okay. What? We're about the same. Yay, US and China, we're climate superpowers. So long story short, next slide. You know, we started doing blogs, we had these infographics, and suddenly the EPA comes knocking at my door and said, you do sludge? I'm like, I could. And so a lot of my job is that I put on meetings, do exchanges, and I act as an information clearinghouse and a matchmaker between US, particularly between US and China. So working with EPA, Global Methane Initiative, I got to do that around wastewater treatment plants. So I worked with policy folks, we brought engineers. This is an NGO activist, they're an energy NGO think tank. And because of this project, they started doing work on methane emissions from, they started with wastewater. Did you know, Monica, they're actually doing oil and gas now too? See, capacity building. And we also engaged some green finance folks from China. And in the end, after the last project, we produced kind of a best practice guidelines looking at what China was doing, what other countries were doing. Next slide. But probably, I mean, I loved her, but my favorite guy that I brought on board was Do Wenlong, who you could have good conversations with you, James. He worked for a company called Tovin, and that back in 2011, they took over a wastewater treatment plant in the city of Xiangyang. And it's in Hubei province, about 1,000 miles southeast of Beijing. And so they took over this plant that had not been treating any of the sludge. It was on an island, and the island was covered with it. And he told a story when I brought him to Toronto to give a talk. He said, yeah, I went out with my boots to check it out, came back and decided I need taller boots. This was bad. They hadn't been treated, they just had been dumping the sludge. And so they were looking, you know, they've been researching different technologies for sludge treatment, and they really knew they wanted methane capture. And but they had a big challenge that in China, next slide, that a lot of because of stormwater runoff is really bad. I mean, think of cities like Beijing, Shanghai, 21 million people, lots of cement, lots of stormwater runoff. And so you've diluted it. And if you guys know your methane and sludge, you know you need organic matter to make it work. So what Do Wenlong did, which I thought was cool, is he talked to the local government and said, how can I get some food waste? And so again, in China, even sometimes at the local level, environmental authoritarianism, they ordered all the restaurants to every day to put their food waste out. And so his company came by with trucks and took it away. Now the restaurants didn't like this because they actually made money selling it to farms to feed pigs. But they hammered it through, and lo and behold, his plant started being more effective. Now, tell you a story so with food waste, so it's true across China. All their wastewater treatment plants, if they want to do methane capture, they need this food waste. And right now, contrary to a lot of the countries that you were talking about, Emily, in China, 95% of their urban wastewater is being treated, but they're not sludge management. There was like almost almost 4,000 plants right before COVID, and we kind of estimated that only about 50 of them were doing good methane capture. And Do Wenlong, they were using it for creating compressed natural gas for taxis. They have another problem too, is that coal is so cheap that it doesn't make as much sense. Like, why should we generate electricity for ourselves? The Ministry of Ag does not allow you to take treated sludge to put on agriculture, in great part because they don't trust the water utilities to actually treat it safely. But luckily for this issue in 2018, do you guys, okay, what happened in 2018 with waste in China? Does anyone know? Do you remember? Recycling. Well, they no longer import waste recycling. So all of our plastic and other recycling was being cut off. Well, that was the beginning of their war on waste. And as part of that, they've mandated 46 cities had to start experimenting how to collect and sort waste. So they're in a better situation now to actually have the food waste they could give to their wastewater treatment plants. They also just do a lot of kitchen waste plants where they just generate electricity from just kitchen waste and doesn't go to wastewater treatment. Next slide. But there's hope. The 14th five-year plan came out in 2021, and they put in there a national methane action plan. And now, again, part of the war on waste, it's not just fluff. They've become a lot stricter. Local governments for air and water pollution, they have to, they now have policies with clear standards. They have to collect data. They're monitored. If your local government officials, if you don't meet your targets for air and water quality, you're going to lose development money. You're not going to get your promotions. So now they're starting it in the waste sector. So it's kind of exciting if you're a nerdy person like me thinking about wastewater. Next slide. So within that, they also set wastewater methane goals. And again, they didn't make the 2020 to make 90% of their sludge safe, but they've set it for in 2025. But you have to keep in mind right now, the methane action plan isn't out yet. And they had big plans. And part of the big plan, next slide, was to work with the United States. Last year, our two, climate envoy miracle workers, in April, they passed there was a US-China climate crisis statement that included methane. But then at the Glasgow, the 11th hour US-China climate declaration, they should just called it the methane declaration. So much of it on methane. They were planning in early 2022 to create a US-China methane working group. But then there was that war in Ukraine. And so it didn't happen. And so there is potential. I mean, so China, they've kind of teed up. They do want to take action on this. And one point that's important to note, maybe go back a slide, because that was kind of, I meant to say, besides the 14th five-year plan, they also, in 2020, 2021, Xi Jinping set a 30-60 goal. Do you guys know that? So by 2030, they want to cap their CO2 emissions. And Xie Zhenhua clarified last year, he's the Chinese envoy, he said, also that means for our non-CO2 greenhouse gases. And then by 2060, they want to go carbon neutral. Every single industry in China, every single government agency, you all have to have a 30-60 plan. You have to be showing that you're going to cap no matter what you're doing. Like, it makes sense if you're the energy company, but I mean, even like tourism, hotels, everyone has to show it. So wastewater treatment plants and the other sources of methane, in ag, there's also a ag plan for what we're going to do with animal waste, better soil management and stuff. So it's kind of like an institution in waiting. And in some ways they're waiting for the US, but also I think they're also talking to the Europeans, but so next slide. I actually just got a grant where I'll be doing some different kind of methane work. I didn't get to tell Monica this. It's not just methane, but we have a grant called Cultivating US and Chinese Climate Leadership Around Food. And so methane coming from agriculture will be one of our little bits and pieces. And I will stop there. Thank you so much. And so now we want to take some questions. And I guess how the tech works, because we're on a webinar, I can bring the microphone to you and then I will scurry it back to the speakers. So do some of you have a question that you'd like to ask any of us up here? Question? Yeah, okay. And when I give you the mic, and just say who you are and where you hang out. You seem to know some people in the crowd there.
Hi, Anne Brigetta with Stantec, and this is a question for James. I was interested, you mentioned regulations, the 300 contaminants that you're monitoring for, and you mentioned PFAS. And so I was wondering, of the contaminants that you're monitoring, if PFAS, like what the levels are and what your stance is on that in wastewater liquid and solids. Thanks.
Yeah, thanks for the question. We have measured it. Past couple years, we've done a few of the commercial lab analytes. That's the 26 analytes, includes PFOS, PFOA, PFBS, and various ones that you do in a commercial lab. Right now, we're actually doing a university study with Purdue. They're sort of the leaders in perfluorinated compounds to look at a larger select group of analytes as well as precursors. So those are, like the fluorinated compounds that might transition into those more stable long chain or short chain PFAS compounds. So definitely looking at it. The levels that we measured so far are sort of what you would expect for a municipal wastewater plant. So you're in sort of, for particular in PFOS and PFOA, you're in low parts per billion. And that's what you see at just municipal levels because it's in our bloodstream. And it's just in all these different products. It's in our clothes. So ultimately it ends up in the waste stream. And so we're sort of at that ambient background level. Compare that to, say, plants in Michigan, where you have significant industrial sources. They're going to be 100, 1,000, 10,000 times what our concentration would be. And I definitely am glad that the EPA is focusing on those source control avenues, because that's where you can really deal with it. Once it gets to us at the wastewater plant and the influence, it's at parts per trillion. That is really difficult to deal with, like really, really difficult. And then, of course, the EPA Health Advisory for water is in parts per quadrillion, which, of course, the analytical methods don't even measure, so that's pretty challenging to meet. And what we found in terms of long-term biosolid studies, there's been a few that have looked at land application. There's a great study in Pima, Arizona. In fact, the authority there halted biosolids land application for a year, where they studied what is the impact, in particular, to our groundwater resources, because Arizona is very sensitive to their the quality of their groundwater. That's what they rely on for most of their supply. And they looked at 10 years, 20 years land application. Their municipal biosolids, very similar levels to ours, probably about twice as much in terms of the base analytes. And they found that after about 6 feet, you get a pretty strong level of attenuation in the soil. And interestingly enough, when they looked at soils that had never received biosolids, just regular ag soils, you saw similar ambient levels, low parts per billion, 1 or 2 parts per billion. Again, indicating that it's endemic. It's not just in biosolids, it's in agricultural supplies, fittings, coatings. Ultimately, that's going to end up in the soil. And so, again, we're at the stage, and the EPA is trying to understand what is the levels that are acceptable. But ultimately, when it comes to biosolids, in particular municipal ones, where you don't have large industrial sources, the impact on the soil by eliminating biosolids land application is going to be fairly minimal. So my opinion, and sort of how we're addressing it as the authority, is until there's new data suggesting that these levels are bad. And again, if those levels are bad, if low parts per billion in the soil are bad, do you know what that means? All agriculture is poison. So that's kind of bad. Now, we can take a step back and say, wait a minute, if all the ag sector is poisoning me, why are we not all dead? This is a great question. And that goes to the health risk assessment that the EPA does. And they've basically applied like 1,000 or 10,000 level of safety factor on their health advisory, which is fine because they're trying to measure what's the lowest level that won't impact health at all. But you have to this has to be a balance of like, well, what is the impact? The level that they set it at, the parts per quadrillion, is based on studies on vaccine efficacy. Okay, that's great. Vaccines, we want vaccines to work, right? What vaccines do they look at? They looked at diphtheria and they looked at tetanus, okay? How many cases of tetanus occur per year in the United States? How many? You guess? About 10. Okay. The ones that are deadly, guess what? The people who don't take the vaccine. Diphtheria. How many cases of diphtheria have there been in the past 20 years? 15. So if the vaccines are ineffective, in particular, this is looking at vaccines in children, shouldn't we see a societal effect? I'm not saying there's not other impacts, other cancer-based impacts, but that is the level that they set the health advisory at. And so if that's the level of conservative approach that we're taking to health risk, then you're basically saying we should never do anything ever because everything has a risk. You just have to take in the probability of a risk occurring. Is it 1 in a million? And what is that benefit relative, or what is that risk relative to the benefit of reusing biosolids, generating energy, offsetting chemical nutrients? So in my mind, you have to look at the whole view. And again, if research changes and it says there's a like 1 in 10 chance of getting liver cancer or something like that, well, that changes the risk assessment. But I'm just reading the health advisory that they released a couple months ago. That's my understanding. So again, we're going to continue with our program until the EPA changes or state level regulations change. So that's where we're at now. Sorry, that was a bit of a long answer. I can talk forever.
Yeah, you get him out of his boots and he's having a good time. Some other questions or comments from out here? Yeah, okay, hold on. Get it over to you and just say who you are for the grander world.
Thank you so much. My name is Rogelio Avendaño. I'm from Mexico. I work for Tetra Tech. And it's more like a question and a comment for EPA in USA that probably on some of the ideas that can be done in the future. What we found on the USAID SURE program, Scaling Up Renewable Energies, it was the implementation of the auctions. The first experience was in Mexico. It took us like 3 or 4 years to assemble the auctions. Unfortunately, we were able to mobilize around $9 billion in investments. The lesson learned from that was the toolkit that lately or later SURE developed for making auctions in other countries. This toolkit included the legal, regulatory, technical, economic, social, environmental, financial, all the scopes, all the spheres that were required to carry out successful auctions, because every country is completely different. So that toolkit in the experience probably could be done between both agencies to identify all those areas and precisely start answering questions, for example, at what scale and in what context we can do, because every country is different. I was thinking in Mexico, probably we need 300 liters per second to make a cost-effective biodigester, but probably in other areas and with different conditions, it could be lower the effluent that we need, and it's probably also the cost of energy. For example, in Germany, it would be extremely small, the biodigester, to make it work because energy is more expensive. So, well, it's just a set of ideas, and probably that would be my question. Is there any potential activity in the future where this could be developed? Thank you.
So are you taking it, are you pointing to? No pressure, it's yours.
So I will say that the research questions we posed, we think will need to be answered through methods like that, by looking at context in detail and seeing what it would take for all of those different kinds of areas, financial, operational, blah, blah, blah. And so we are pushing forward with that. We do have a current mechanism to start that research. And so it's not clear if we'll have a future opportunity yet, but do keep a lookout. Yeah.
I also wanted to ask, did you have a question for, or do any of my panelists, do you have a question for each other? Oh.
Okay, address but I actually have a question that I think would be interesting, because I've heard from Jennifer that a lot of the Chinese wastewater biodigesters were actually kind of started or worked with DC Water. So if either DC Water or if James or Jennifer could maybe expand on that, would be really interesting, that it was almost sister cities. I don't know if Jennifer.
Do you know about that there was, Yeah, well, one of your colleagues, one of your Chinese engineers, but also some team went over to Beijing, and they, using the same technology that you guys have, was trying to help Beijing, the city Beijing, to launch it. I mean, back in 2015, they were only treating about 23% of their sludge. City of 21 million, ergo the big hills outside the city. But yeah, I mean, I don't know. I mean, I think it was having a bit of a bumpy start, and I think again a lot of it went down. There's other things besides not having enough, not organic material. There also was a lot of it was still voluntary, and that's kind of the hope with the new regulations. Because if you're having a war on wastewater and sludge and methane, that they're going to have to start making it a requirement. But they're hesitant to do some of that because until they actually have the right kind of data and that they can measure it. So there's a lot of little things that have to line up. But they're definitely, they were waiting for us, the U.S., to work together on this.
Yeah. I don't know about partnership with China. We have worked with a lot of different countries though. I've been in meetings with folks from Mumbai and India. We've had people from Peru, Lima, Bogota, Panama, and we've been pretty open. Our general rule is if it's a utility, we're happy to share all of our data and our understanding. In particular, when it comes to the residual management, that's the component I know, like about how, what's the quality of the material that you're going to get and how can you market it and sell it potentially. Because a lot of organizations are interested in that, where they have restrictive options for what they can do, or they have to go really long distances. Canada comes a lot too. Vancouver, Calgary, Toronto. Man, Vancouver sends their sludge like 1,000 miles to a mine. It's crazy. The Lower Mainland is all ag. But again, I guess it's a similar idea of not trusting the sources. So yeah, there's a lot of utilities that are interested in, and also in the U.S. as well. Because we're the first plant in the U.S., that was actually a pretty big development. If you know utilities, they're very conservative, and often when it comes to infrastructure upgrades, you have to see a pilot unit or a full-scale unit in the United States in order to adopt it, which kind of creates catch-22 of technology. Like, well, how do I get it in the U.S. if you require it in the U.S.? And we actually had to overcome that because in our own procurement guidelines it said that. But once we were there, we get visits from all different cities. Dallas, Columbus, San Francisco, Los Angeles, have all come at Richmond, have all come to look at our facility and ultimately gone ahead with master planning on using this kind of technology because of the net benefits, not even the marketing, just the residual stabilization and the biosolid reduction. So we do get a lot of inquiries, do a lot of tours, which is fun. I really like doing that. It's fun.
And there's business in it. I mean, like the Mr. Doe who I was talking about, he was a businessman and he saw the potential of them making money from it. And I think so he now goes around China and consults in different cities to tell them like, this can work. Anyone else want any? Yeah, Emily, do you have anything question? Do you want to ask?
Yeah. So, I wish I could link it to the last question, but I was too busy organizing my thoughts. I was reflecting on the different aspects of maybe the broader enabling environment that have come up in all three of our talks. And I just want to share those and get feedback on if there's any other ones. So I noticed from Monica's talk that energy and financial incentives and feasibility broadly. I noticed from James like a balanced health and energy regulation kind of landscape where trade-offs are like assessed. I heard from you, Jennifer, that like food waste strength is important. And also maybe environmental authoritarianism can be helpful. Maybe that's not feasible or wanted for other reasons, and then just like, I think broadly, technical capacity and resources in my case, at the utility level and governance as well. Any other reflections?
Not to trip on any points.
Hi, my name is Jette Finsen. I'm with DAI, and it's more reflection. And I was wondering about this. As a couple of years ago, I was doing a study in the Philippines where we were working with the government to to develop a model of greenhouse gas emissions for all sectors for use in their NDC and for setting the target. And wastewater was one of the sectors. And so we were, and it was kind of like last minute, you know, there was a lot of focus on agriculture and energy, and wastewater sort of got in there last minute because we had to do a national model. And the data wasn't there first. We had to educate. There wasn't a clear, how do you say it, who's responsible for the data and for the wastewater sector. And so first we spent a lot of time, and it was actually really useful for the stakeholders just getting the data, because they thought first that it was just a matter of checking the utilities, the wastewater treatment facilities. But then it, you know, when we got into it, it was the piping system, what is the fecal sludge management, the whole thing, and they didn't have the data on it. So I think there's and just going through all that and seeing where are the emissions associated with each of those steps and where are the gaps, because in some places we don't even know what the emission factors are. So I think it would be really useful also if for USAID to also work at that national level on the strategies, to inventory it, because and getting the right stakeholders together, because they were at least in the Philippines, the stakeholders weren't there. It was a 2-year process, and it became really interesting from the findings to see that if there was a big push to move wastewater treatment into centralized facilities, but if you do that, you increase emissions, and it raised a lot of discussion. So I think it's from that perspective, if you're working in the countries we're working in, we also need to develop the overall capacity, and that's probably also how you link to climate finance, if you have that bigger picture. So beyond that research, which is really useful, it's also the data and the right stakeholders, so you can deal with James' issue of the regulation and the incentives.
If I can interject there, that like I know USAID doesn't operate in China, but in China, your sister organization in Germany, the GIZ, they work a lot in China on methane, on waste and wastewater, and doing exactly the things you were talking about, building the capacity. So I kind of hooked up with them when I did my study tours as well. So you should, if you need a contact, you probably have some, but they might have some good insights. And they're not working in every country of the world on this, but they are in many. Some other questions or comments? I know. There's James, the strong silent type here. Yeah.
Yeah, I wanted to go back to what Emily was asking for incentives. I would say in terms of incentives for us improving the quality of the biosolid, it all came down to logistics and cost. Before we upgraded to Canby anaerobic digestion, we made about 1,100 wet tons per day of Class B biosolids. That our annual budget was about $20 million, and the projection was land application costs would only increase, land use for Class B biosolids would only decrease because states were getting more restrictive on what land you could actually use Class B biosolids on. So that was kind of our driver. And I would say, like, for the lower scale, and this is my understanding, at least with Sanergy, and they're sort of in the peri-urban environment, there's always a cost. There's a cost to draining your septic tank or your leach field. There's a cost to dredging out the urban latrine. And it's about how do you make the business work, for whatever logistics costs exist there, because that was certainly what drove us ultimately. And again, it was we saw a return on investment because we went from a budget of $20 million a year. Now we're like $4 or $5 million a year, and then also the energy cost saving. So I would just say that as one of the drivers.
This is to you, James, now for DC Water. So just kind of in this conversation, if the economics didn't make sense, would that have ended the methane capture? Was that really the baseline driver in your?
It was a discretionary project, right? So there's some projects in our CIP capital planning that we have to do, right? If the pumps break, you got to fix them. Otherwise, the water doesn't get to the wastewater plant. But there's no return on investment for pumps. Replace a pump, it's not going to save you money. You just have to replace it again. Same with pipes. This was a longer term effort to plan for the future, recognizing, like, when my boss started in 1999, you know, he came to Blue Plains and there was basically a mountain of sludge, you know, like 50,000 tons just sitting, sort of like in China, the same thing in Beijing. You know, DC is not that much better, even though we have the regs. And they didn't have a lot of places to go with it. The contractors were kind of running roughshod over them. You know, it's back in the Marion Barry days, so contractors were a bit funny. So they were already concerned with how they were going to manage that residual. And so there was that driver, but it wasn't required. So when they prepared the proposal, it had to have some kind of return on investment because there was no consent decree, there was no driving regulatory force, just projections and also the desire to make management simpler by virtue of having less volume. But, you know, that's one nice thing, you know, if you're able to make a business case, it takes, you know, that took a decade, and similar with like projects that have 1 or 2 year ROIs, it takes me 4 or 5 years to get them approved, but they do get approved because ultimately, you know, there's a cost to running a utility and we can only raise rates so much. So if you can make a business case and you stay sort of committed to it, you can sometimes get that interjected. But yeah, it was totally discretionary.
Before you and I were talking about this, and what about because I gave him an example. One of the places I took my Chinese groups to LA. I mean, come on, LA is fun. And here I take them, like, not to Disneyland, but to wastewater treatment plants. And there's one plant in LA County that's 100% off the grid. They power themselves 100%. You guys only 30. But they also sell compressed natural gas. And that's because the regulatory incentives were saying, California said, California Air Resources Board, the California state requirements for zero emission vehicles. They need a lot of compressed natural gas. And they were providing it. And then the state said, no more food waste in the landfill is coming soon. And so then Waste Management and these other companies started partnering with some of the wastewater treatment plants, particularly the one in LA County, whose name I forgot, I'm sorry. But it's a great plant. I mean, now they have 4 digesters now, and they're producing a lot of compressed natural gas. And again, kind of like you on the East Coast, a lot of people come to you and look. But what about the compressed natural gas? Wouldn't that be a good moneymaker for DC Water?
That's a great question. It would absolutely be a great moneymaker. We've been looking at this for years because there's a program at the EPA called the Renewable Fuel Standard. It sets a price for if you can send your CNG that's renewably generated to a vehicle, you get like $3 per, I can't remember, million BTU. I can't remember the conversion. But anyway, it would change the economics substantially. Our gas right now generates a net benefit of, you know, a few $1 million of offset energy usage per year. That's generating, we have 3 4.8 megawatt turbines. Generally, 2 of them are operating. If we were to send that into the natural gas grid and sell it as a RIN, it would generate about $30 million a year in revenue. And we've been talking about this with our executive for like 5 or 6 years and been like, look, the capture infrastructure is just like cleaning, get rid of more CO2. You meet the gas pipeline quality gas. It's only about $20–30 million. It's literally an ROI of 1 year. But you know, we're utilities. It's a little bit too complicated. You know, we're not a gas company. We sell water. How can we sell gas? So yeah, the economics are awesome, especially if we sold it to California because the Air Board has the added incentive. But yeah, so again, it's just these things take time, even the best program, because you have so many obligations in your CIP, and if you know wastewater, your revenue from rates only covers like 40–50% of your capital, if that. So you're always running at a deficit. So that's always a challenge.
Now, DC Water and LA are big cities, and that Emily, she was not talking about not big cities, but also, Monica, you mentioned as well that in some of these other countries where you're working, is there any, I'm asking you and also the people here, are there some pilots or some clever thinking on how can we take, because Emily's goal of getting this into the sanitation area, having it be money making could be very helpful. Do you want to?
So this is definitely, I think, the reason I was asking James about the DC water and the finance, the logistics or the incentives is because I think that is one of the key goals is if there's no incentives, if there's no financial incentives or regulatory incentives, then I think the smaller wastewater facilities or even just the smaller towns, there's not a lot of reason to do this and it's costly. So I think that's something that we've been definitely thinking about. And again, I would like to explore this a little bit more tomorrow with Mexico and Kazakhstan, our speakers. And also if there's anyone in the audience that could talk about this, this is something that I don't have the answer to. And I think it's more of a discussion of trying to figure out what is the moneymaker. And I know my colleague Lauren is here and she has dealt with this on the domestic side in landfills, looking at how, what is the financial incentives? Is there a moneymaker to it? Is there places that we can try to figure out how to bring in financing through this? I don't know if, I don't want to put you on the spot, Lauren, but is there anything that you can talk about or if anyone else?
Will anyone save Lauren as I'm walking to her to hand her the microphone? You're on the spot, Lauren.
Great. So were you talking specifically about food, the food waste part, or no? Just incentives for biogas. Maybe I'll take the food waste route because we've seen in the US that many landfills, especially on the East Coast, are running out of room, like they're reaching the end of their life. People that manage these landfills want them to last as long as they can. And so an option they have is diverting their organics. And so they have to find somewhere to send those organics. And one option that we present and people use is to send them to wastewater treatment plants that have digesters that have extra room. So that's a really great model. I know there's a few good examples out there, but I think there's just challenges because now you have like two government entities that need to work together. It needs to make sense for both parties. You probably have another trucking issue where you need to get that organics collected, make sure it's clean enough for the digester to accept and then get it to the digester. So it's interesting challenges. And as far as incentives, I mean, just beyond, you know, expanding the life of that landfill for the municipality, there's of course the RFS that James already mentioned, LCFS, those are the fuel, you know, incentives if that treatment plant or the digester is making renewable natural gas, but that's not always what they're doing. They could just stick to CHP. So it's a complicated mesh of options. Yeah.
And we have another question.
Thanks, Anne Brigetta again with Stantec. So I appreciated Emily's context of the broader enabling environments for these 4 different talks and the 4 different challenges faced. And I'm thinking about it from a broad climate perspective. We've got the mitigation with the methane emissions, but then from an adaptation perspective, Virginia's very lucky because we don't have water scarcity issues. So the actual water that's being returned from a wastewater treatment plant is, you know, returned to the river perhaps, but in a water scarce environment, it would be different, right? In San Diego, you would have complete reuse. So your circular economy not only focuses on the carbon, methane capture, but it focuses on the solids and it focuses on the water as well. So I think that pertains to the developing world as well as the developed world. And I was wondering if any of you all had thought about that component to it of the water itself in that recycling circular model.
Who wants it? Emily?
Yes. It's fine. Our programs in the Middle East are thinking about this not from a methane perspective, but they really are doing wastewater treatment at a larger scale. It's not fecal sludge treatment for that reason. But yeah, maybe it would take a little extra to also do methane abatement. Maybe it's like scarcity of the reused resource, like if maybe fertilizer, for example. So yeah, I think beyond water scarcity, there has to be something else that's scarce as well.
Yeah, I got a lot of thoughts about water reuse. In my previous job, I used to do research on it. And so I think, again, in California's perspective, I mean, you're dealing with a scarcity issue that's driving it, but it's also a cost issue. Direct potable reuse is the cheapest option. It's cheaper than desalination. it's cheaper than building a new dam, which apparently is the only reason they don't have water, according to farmers. So I think again there's a clear cost driver there. You just have to get over the sort of the regulatory hurdles. It took a long time for them to approve direct potable reuse because there's a lot of aversion to it. On the climate side, though, of course, you're having to use a lot of extra technologies. You have to use some kind of carbon removal system, and then you're using membranes, ultrafiltration followed by reverse osmosis. So that's pretty energy intensive. I guess what you would say is compare that to their other alternatives. Like you look at Carlsbad and you're like, okay, well, they're desalinating seawater. So clearly the energy density is much higher. So I guess that would be a way to look at it from a carbon perspective. I'm not sure how the cities do it, but I do know from like a cost management perspective, DPR is best. Indirect potable reuse, again, I mean, you're adding added costs, like you have to pump it into the reservoir or the aquifer, and then you have to pump it out. And I think part of that is you can have a lower treatment standard because we're like, oh, it goes to the ground, so that's better, which is interesting because if we look at these micropollutants, it's probably not better because you're like, okay, now I'm putting in the groundwater all the perfluorinated compounds, I'm putting the microplastics, I'm putting all the other micropollutants. Whereas if you're doing RO, now you just have the brine. Of course, you have to figure out what to do with the brine residual again. I think that's one thing with wastewater. It's like, you think about these things, you put it down the toilet, you don't think about it, but there's always these residuals. They have to go somewhere, and that's where, I have a challenge because I'm thinking, okay, if we can't do land application, landfills are like, we're filling up, we don't have space, there's no incinerators. I'm like, what am I supposed to do? It has to go somewhere. So we have to have trade-offs. There's no perfect solution. We have to have trade-offs on what is the overall net benefit for the environment, for human health, for aquatic health, for terrestrial mammal health. So again, it's I think again, it's just there's a lot of drivers for that one, and I think in certain contexts, like it makes a ton of sense.
And I think this is actually a really interesting point. My limited experience just working on this is that you're dealing with different agencies in a developing country or in a developed country. And so sometimes they don't think about the kind of the overall perspective. They're thinking, I'm a water agency, or I'm a Ministry of Environment. And so what's been really challenging with wastewater and methane capture is that you're working at different agencies and they don't talk to each other. And so maybe this is somewhere that we look at, something that I realize that there's a cost and there's difficulty about the reuse part of the logistics of it. But it's something maybe to explore, to look at, to think about. And I think it's a very interesting point.
On the governance side, I mean, as part of their reforms, the war on pollution catalyzed in China was that their ministry, now it's the Ministry of Ecological Environment, they were given all responsibility. I mean, there is a Ministry of Water Resources, but they were given like supreme right over water finally, and they were also given climate. And so now the challenge is how you have that trickle down. But I mean, I think China, again, I mean, I joke about it, but the environmental authoritarianism thing can be helpful in certain situations, kind of forcing the government agencies to work together. And the seriousness of the climate targets, I mean, Xi Jinping has bet his political future on it. I mean, I don't know, he's going to become the, president for life soon, but still, the public wants to see this. And so, I mean, I think, and they have experimented in some cities where they actually brought together the energy, urban management, and water bureaus and made them a single bureau. That's China. That's China. But then you look at, Singapore, which is not just Chinese. I mean, Singapore with their, did you ever go to Singapore? That is either the new water and that, I mean, that's water. I mean, that's what, toilet to tap. I mean, they make no bones about it. And China was experimenting with it, and oddly, they in Beijing, they did it in a very decentralized way. And it was a complete failure. They told building managers that you're responsible, that you're they tried to put recycling facilities inside each building. failed miserably. Like this is it needs to be more centralized. You can't just have some apartment building recycling your water.
Well, thank you very much. Thanks. Thank you for all our panelists plus Jennifer. Thank you again. I know it's 5:30, so we have a DC water tour, which is super exciting. So I'm going to actually